In this video I'm going to show you how to do a quick and dirty stress study on a small truss so that you can get rough results for your popsicle stick bridge competition. I've already created a sketch in SolidWorks of this small truss. Let's edit the sketch so you can see what it looks like. I've basically drawn some lines and given it some critical dimensions. The stress study is going to require me to have a solid model, so that's my next step, is to take this sketch and create a solid model from it. So let's go ahead and do a center rectangle along this top rail. This center rectangle will represent the width of a popsicle stick along that center rail. Let's dimension this to 3/8 wide, 0.375, and we'll take this and put it on the midpoint of that line. We can also do the same to the bottom rail, and we'll take this and make it equal in length to this one so we don't have to dimension it as well. We'll take this one and this one, put those on the midpoint. Next, let's use the 3-point center rectangle, and I'll just draw one here. Now I can place it using constraints. Let's take this point and the midpoint and place them together. Let's take this point and the midpoint and place them together. And of course we'll take this line and make it equal in length to this so that the popsicle stick is the same width. Now eventually in our design process we'll have to figure out how to make this joint work, but for now, for our quick and dirty stress study, we're just fine with this. Now we can just draw a bunch more of these centered rectangles. And our goal is to have a centered rectangle along each one of these members. And we're going to use these centered rectangles to actually make solid. So go ahead and pause the video and get that finished. Now that we've created a rectangle on each of the members of the truss, we can finish the sketch. Next, let's go to our Features tab and do an extrusion. Let's extrude this one first, and we'll go 0.0625 inches. Now we want to do another extrude, but the sketch has now disappeared. But that's okay. We know that it's just embedded in this first extrude. We could click on it and show that sketch. Now when we do another extrude, I can just click on this rectangle. And again, we want that to go 0.0625. Now here's another key. We do not want to select Merge Result, because that will blend this first member with the top member, and they'll blend them together as one single solid. We want the two to be separate solid bodies, so we uncheck the Merge Result. Let's go ahead and do that to each one of these rectangles. Uncheck the Merge Result. Go ahead and pause the video and do that to every one of these rectangles so that you have a separate solid body for each one. You'll notice that you have a separate solid body for each one because up here in this folder it'll show you how many independent solid bodies you have. Right now I have 3. By the time we're finished we should have 10. So go ahead and pause the video and finish that part. Okay, now we should have 10 independent solid bodies. Come here to this folder and make sure you've got 10, because we're going to treat each independent solid body as a beam member when we do our stress study. And now that we're done looking at the sketch, we could actually come here and turn off the visibility for that sketch as well. Now you'll notice you see some overlapping solid bodies, and we're not worried about that now because we're just doing a quick and dirty stress study, and we're going to treat each of these solid bodies as a separate beam. So next we're ready for our stress study. We'll come here to this Simulation tab. If you don't have that tab, just right click and make sure to turn that tab of tools on. And in that tab, the only tool that's available now is to create a new study. And look at all the different types of studies we can do. Static, thermal, frequency, buckling. We're just going to create a static study. Notice it now adds this new feature manager below the existing feature manager. I could resize this if I wanted to so that we could see more of the features that make up the solid body. This feature manager down here talks about the features that make up the stress study. If I click on the plus sign here, you'll see all the solid bodies, all 10 of them. I want to change those, so I select the first, hold down Shift, select the last. It will select everything in between. Let's right click and treat all of those selected bodies as beams. Notice the icon has changed so that it looks a little bit like an I-beam. Now they're all treated as beams, and it wants to create joints in between each beam. Let's right click and edit that, and we're going to need to recalculate all the joints. And it tells us that it's having problems creating joints due to short beams. This truss is so small that it's giving it a little bit of grief. But let's hit OK, see if it can really find it. It doesn't think it can find the joints, but I think it can. And sure enough, it did find the joints. See these little purple dots? That's where it's creating a joint between all of the beams. So we'll hit OK. Next thing we can do is come to the fixtures. If I right click here, let's add fixed geometry, and instead of fixed geometry we're going to select immovable. And we're going to select this joint to make it immovable, as well as the joint here on the far right side. Those two will be immovable joints. We hit OK. Next we're ready to place an external load. Let's right click and place a force. And we're going to place a force not on a vertex but on a joint. So let's select joint, and we'll select this joint here to place a load. Now we need to specify something that will indicate the direction of the load. So I'll select in this pink area here, and I'll just select the front face. That'll help SolidWorks know which directions, vertical and horizontal, etc. And I can place loads in any of these directions, the horizontal, vertical, or in the Z direction. Let's place a load here in the vertical direction. It's going to be in newtons, so I can change that and put it in pounds. Let's put 80 pounds. And notice the icon is showing the arrow going upward. We want the load downward, so we can reverse the direction. Now the load is going downward on that truss. 80 pounds, and hit OK. Now that I've created joints, placed the immovable fixture, and created an external load, I'm ready to run this study. I'll right click, and I'm going to choose to mesh and run the study. And notice it's showing me the stress, upper bound axial and bending stress in newtons per square meter. Well, I'd prefer to see it in psi of stress. So let's come down here to this stress study, right click, and edit the definition. Instead of newtons per square meter, let's show it in psi. And let's also go to chart options, scroll down, and instead of showing it in scientific notation, let's show it in floating point notation. And there's no sense showing any decimals. Let's show 0 decimals. Hit OK. Now that's showing us this upper bound axial and bending stress in psi, red being high, blue being locations of low stress. And we can see here that this member is the high stress member. It's going to be in tension, but it's still under 5,000 psi. And we figure that birchwood, the standard material for popsicle sticks, can handle about 5,000 psi. Let's see if we can increase the load. I could right click on the load of 80 pounds, edit that definition. Let's change it to 100 pounds and see if the truss can hold 100 pounds. I'll have to run the study again. Now it's showing that it's just over 5,000 psi, so that truss will not quite be able to hold 100 pounds because the wood will only be able to handle about 5,000 psi of axial and bending stress. But let's see if we can make some additional changes. Perhaps I do want it to hold 100 pounds. Let's see if we can change aspects of the design of this truss. Let's go back to modeling, and let's edit this original sketch. Instead of 4.125 inches, let's change that. Let's make it a little bit longer. Should we make it 6 inches long? So it's a deeper truss. Now this may be so deep that it won't fit in our testing machine, so we've got to be keeping that in mind. But let's just see what happens to the stress. We'll finish this sketch. Let's go back here. Notice the tabs on the bottom. Our static stress study is right here. We'll go into that tab, and we'll notice that our joint group now has an exclamation point, a warning sign. So we'll need to right click and edit that and recalculate the joints. And again, it's saying it's having problems. Now this is a little glitch in SolidWorks. It did create the new joints down here at the bottom, but it looks like it kept these joints, and that's not very good. So let's hit OK here, and let's find the location of this beam here. It looks like it's number 2 in our list. So let's right click on solid body number 2 in my list. Your list may be different, but let's go and define the beam neutral axis. Notice it's defining the beam neutral axis up here instead of down here in the center of the beam like it should. So we're going to select the direction by choosing on an edge. Let's choose this edge here. Now notice the neutral axis of that beam is now down here. So it should recalculate these joints better. We'll hit OK. Now we can go back to the joint group, edit this, recalculate, hit OK, and it sure does find the joints just right now. So we can hit OK. Now we can run down to this, and we'll right click and we'll mesh and run that study again. Now you'll notice with this deeper truss, even with the 100 pounds on it, the maximum stress is only 3,700, and the birchwood can hold up to 5,000. So making this deeper truss reduced the stress, hence making the truss a lot stronger. So one of the reasons that we made this quick and dirty is because we want to be able to make changes quickly to see what will happen to the stress. There's no sense in us modeling the entire popsicle stick bridge just to find out that our ideas weren't very good. So we save a lot of time doing a quick and dirty study so that we can validate whether or not our ideas will even work.